A clay cylinder seal, no larger than an adult thumb, sits in restricted storage at the Oriental Institute in Chicago. It has not been on public display since 1973. Its catalog number is OIM A2311. It was excavated from the ancient city of Nippur in 1906 during one of the earliest American archaeological expeditions to Mesopotamia, and for decades it sat in the general collection unremarkable, unstudied, filed under ritual objects of uncertain purpose. In 1971, a graduate researcher named Patricia Coyne-Cross referenced the seal's engraved sequence against astronomical records from other Nippur tablets. She submitted a 12-page internal memo to the Oriental Institute suggesting the seal was not a ritual object. It was a positional record, a compressed astronomical notation system encoding the movement of something across the sky over thousands of years. The memo was filed. Coyne left the institution the following year. The memo has never been published, and the seal has not been re-examined using modern imaging technology. What makes this significant is not the object itself. It is what the object points to a pattern in Sumerian astronomical records that modern geophysicists did not discover until satellite mapping began in the 1990s, and which has quietly unsettled every researcher who has looked at both sets of data side by side. The Oriental Institute was founded in 1919 and remains one of the most respected Mesopotamian archaeology institutions in the world. The Nippur excavations conducted between 1889 and 1900 produced over 30,000 cuneiform tablets, the largest single recovery of Sumerian written material ever made. The majority have still not been fully translated. OIM A2311 is a verifiable entry in the Institute's catalog. Physical access requires institutional affiliation and a minimum 6-week processing period. The broader context matters here. In 1903, Dr. Hermann Hilprecht, lead excavator of the Nippur site, documented that certain tablet groupings appeared to encode cyclical time records rather than administrative or literary content. That observation received almost no follow-up from subsequent scholarship. It was noted, cataloged, and set aside. And separately, in January 2019, the World Magnetic Model, the navigational reference, maintained jointly by the British Geological Survey and the National Oceanic and Atmospheric Administration, had to be released 6 months ahead of its scheduled update cycle. Magnetic north was moving faster than any previously recorded measurement could account for. The model had become inaccurate faster than anticipated. For decades, researchers working on the broader Nippur tablet collection treated a subset of astronomical records known as the MUL Appen series as a sophisticated but straightforward star calendar, a record of rising and setting positions for key stars across the Mesopotamian calendar year. That interpretation is largely correct. When modern astronomers back-calculate where those stars would have appeared from central Iraq at the time the tablets were composed, the positions match the sky as it looked around 2300 BC. But there is an exception. A cluster of positional notations in the third section of the MUL.Appen tablet group describes star positions that do not match 2300 BCE. They are displaced. And historian of science Luz Brack-Bernsen, in a 1999 paper published in the journal Centaurus, proposed that these displaced notations may not be errors or later amendments. They may be projections, future positions, calculated forward using a tracked drift model. The standard response to this observation is Scribal update the idea that later copyists amended the tablets to reflect contemporary observations. This is a reasonable and methodologically defensible explanation. But Brack-Bernsen noted that scribal updates produce a specific pattern. Amendments cluster around known scribal centers and datable historical periods. The positional anomalies in MUL-Appen do not cluster. They are distributed throughout the tablet series in a pattern more consistent with systematic projection than with piecemeal correction. The Sumerians were not just mapping where the stars were. The evidence suggests they were tracking where something was going. But that is only part of it. Earth's magnetic field does not move in lockstep with its rotational axis. Magnetic north drifts sometimes slowly, sometimes rapidly, and geophysicists track that movement through satellite observation and through paleomagnetic records, the preserved magnetic signatures baked into ancient lava flows and lake sediment cores. Those cores reveal something that is now well established in geophysics. The magnetic field has not just drifted. It has collapsed and reversed completely at least 183 times in the last 83 million years. The most recent near reversal, known as the Laschamp Excursion, occurred approximately 42,000 years ago. During that event, the global magnetic field weakened to roughly 6% of its current strength. It partially reversed its polarity. Then, over approximately 1,000 years, it recovered. In 2021, a study published in the journal Science, led by Alan Cooper of the South Australian Museum and Chris Turney of the University of New South Wales Cross, referenced the Laschamp Excursion with archaeological and fossil records from multiple continents. The timing aligned with the extinction of megafauna in Australia, the disappearance of Neanderthals from Europe, and an abrupt expansion of cave art and symbolic behavior among early modern humans. The researchers proposed that the collapse of the magnetosphere produced a prolonged period of elevated ultraviolet and cosmic ray exposure at Earth's surface, with cascading effects on climate, ecosystems, and human survival patterns. They named it the Adams Event. That is not a fringe hypothesis. It appeared in one of the most peer-reviewed scientific journals in the world, authored by researchers at two separate institutions, based on independently corroborated datasets. The mechanism the Sumerians could not have named magnetospheric collapse produced exactly the scale of civilizational disruption that appears in ancient catastrophe traditions across multiple cultures. If you follow ancient history and the intersection of modern science with what early civilizations actually recorded, this channel covers that ground every week. The material that sits in institutional archives and peer-reviewed literature and rarely makes it into the same conversation. Subscribe if that is what you are here for. The current weakening of Earth's magnetic field is not a hypothesis. It is one of the most consistently documented geophysical trends of the past 2 centuries. Since Carl Friedrich Gauss made the first systematic measurements of global field strength in 1840, the overall intensity has declined by approximately 9%. That rate has accelerated in recent decades. The South Atlantic Anomaly, a region of dramatically weakened magnetic field centered over the South Atlantic Ocean and extending across Southern Africa, has grown measurably since the 1970s and is now large, enough that satellites passing through it experience elevated rates of unexplained electronic malfunction. NASA has publicly acknowledged this and adjusts satellite operations to account for it. Magnetic north, which moved less than 15 kilometers per year through most of the 20th century, began accelerating in the 1990s and is now moving at approximately 50 kilometers per year directly toward Siberia. The European Space Agency's Swarm satellite constellation, launched specifically to monitor the magnetic field in 3-dimensional detail, has identified a second region of accelerating change forming beneath the African continent. Here is where it gets specific. The cylinder seal OIM A2311, as described in Patricia Coyne's 1971 memo, encodes 7 positional notations. Coyne identified 5 of them as correlating with historically documented magnetic north positions across a span from approximately 3500 BC to 2000 BC, a period during which the paleomagnetic record shows an unusually active phase of field movement. The correspondence was precise enough that she concluded the seal was not an astronomical record in the conventional stellar sense. It was a magnetic drift record, a multi-generational tracking sequence preserved in compressed notation on an object small enough to survive intact across millennia. The 6th notation does not correspond to any historical position. It corresponds to a projected future position 1 that, based on current drift rates published by NOAA, Magnetic north will reach somewhere between 2040 and 2060. The seventh notation has not been decoded. Coyne's memo describes it as a terminal marker, a position she could not place in either historical or projected data using the tools available in 1971. She noted only that it lay significantly further from any position in the recorded sequence, and that it appeared to be associated with a symbol she translated, with stated uncertainty, as the field that does not return. Now, before drawing conclusions from any of this, the mainstream position deserves a fair hearing, because the mainstream position is not easily dismissed. Geophysicists are consistent on this point. Magnetic pole reversals are not periodic, not predictable from a fixed cycle, and not imminent in any scientifically defensible sense. The current rate of field weakening falls within the normal range of geomagnetic variation. The South Atlantic Anomaly has existed in various forms for at least 11,000 years, as demonstrated by archaeomagnetic data from ancient iron smelting sites in southern Africa. This is not a new development. The acceleration of magnetic north movement is real and significant, but pole excursions, partial movements that do not result in full reversal, are common in the paleomagnetic record, and most do not produce widespread ecological disruption. As for the Sumerian records, the Mul.Apen series is a sophisticated document, but reading magnetic pole tracking into its notation requires interpretive assumptions the text does not explicitly support. Coyne's memo was never peer-reviewed. Its central claim was not reproduced by subsequent researchers at the Oriental Institute. The correspondence between the seal's notations and modern drift measurements could be coincidental pattern matching applied retroactively to ambiguous data. That is the strongest version of the mainstream argument. It is scientifically grounded, methodologically cautious, and accounts for the majority of the evidence. It does not account for the atom's event timing. If magnetospheric collapse at 42,000 years ago was a routine geophysical episode, the simultaneous convergence of megafaunal extinction in Australia, Neanderthal disappearance in Europe, and the documented expansion of symbolic human behavior across multiple unconnected regions requires a separate explanation. No such explanation has been proposed that accounts for all three data sets at once. The mainstream position handles each element individually. It has not resolved the pattern. When these three things are placed in sequence, the Sumerian astronomical tradition suggesting long-cycle positional tracking, the confirmed paleomagnetic record of catastrophic field collapse within the span of anatomically modern humans, and the current measured acceleration of magnetic north movement, a coherent picture forms, not of prophecy, of documentation. The cylinder seal OIM A2311, if Coyne's reading is accurate, was not predicting a future event. It was recording an observation, a multi-generational sequence of something the Sumerians had tracked moving across their sky, using notation dense enough to preserve the trajectory across thousands of years on an object small enough to carry. The sixth positional notation on that seal corresponds to where magnetic north is going. The seventh has no match in any data set currently available. OIM A2311 sits in restricted storage in the Oriental Institute's research collections building on the University of Chicago campus in Hyde Park. It has not been subjected to reflectance transformation, imaging the current standard method for recovering engraved detail from ancient cylinder seals that conventional photography cannot resolve. Early analysis of comparable seals has recovered complete notation sequences invisible to earlier documentation methods. The seal has not been scanned with micro-CT imaging, which would reveal whether subsurface engraving exists beneath the outer clay layer. Patricia Coyne's 1971 memo remains in the Oriental Institute's internal archive in physical form. It has not been digitized. It is accessible only in person, by appointment, to credentialed researchers with active institutional affiliation, a process that requires administrative approval renewed annually. The Oriental Institute is currently operating with a reduced curatorial staff, following budget restructuring in 2022. Access requests for the restricted collection are being processed on a backlog estimated, in the most recent public administrative statement, at 14 months. The seal is in the drawer. The imaging equipment that could resolve what it actually encodes exists and is in use at institutions 20 minutes from where the seal is stored. The appointment to examine it has not been made.